Alright, so we are going to do two parts today in this video. One, we're going to review reflection a little bit, and two, we are going to look at another rigid transformation called translation. So I just have like a little Desmo screen up here, just pulled up just because it has these triangles that we can move around and manipulate. So a couple things with reflection. Hopefully we learned yesterday, and we wrote this in our notes somewhere, so that way when it asks us a question today we can answer. What does reflection mean? Like if I'm trying to find a reflection of something, what is like the key concept of that? And that's basically to flip the figure. Again, if I look in a mirror, I'm going to be taking this image, and if this is the mirror, it's going to be reflecting. It's going to be flipping over that line. So when I do that, the one thing I want to think about is how far away each of these segments are. So for instance, if this is the line it's flipping over, right? Then I need to count how far away is B from that line. Well, B is 1, 2, 3 away, which means B is going to be 1, 2, 3 away over here. This is going to be my new B. And we label that with the little apostrophe next to it. Here I can do it with this one, so that way I can actually bring it over here. So this one is going to be B prime. It's going to be 1, 2, 3 away from that line. I'm going to do that same thing with A. So A, again, if I were to count how far away it is from this line, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9 away. So I'm going to take this A prime, and again, I want to make it 9 away. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. And then last but not least, again, this one is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 away. So we're going to make it 11 away. So again, notice these figures look exactly the same, but they're flipped over. Okay? Reflection is when we actually flip the figure. Today, what we're going to talk about is translation. But I want to do one more reflection before we do that. Imagine that I have a yellow line right here. And I say, okay, I want you to reflect this figure over here. So we've reflected it left and right. We want to reflect it up and down. So let's look at that. If I want to reflect that up and down, right? So again, I want to look at all of these 3 points, and I want to see how far are they away from this line. Well, C is this far, B is this far, and A is this far. I want to do that on these other sides so that those same points are the same distance away. So looking at C, it looks like it's 1, 2, 3 away. So I'm going to make C 1, 2, 3 away. So C is going to be right here. 1, 2, 3 away. I'm going to do the same thing for B. B is 3 away. So I'm going to make it 3 away. And then A is, let's see, 1, 2, 3, 4, 5, 6 away. 1, 2, 3, 4, 5, 6 away. Perfect. Again, if I look at it, it's the exact same triangle, just flipped upside down. A couple kids are having confusion about diagonal lines. So let's talk about that for a second. So again, pretend like all these aren't here. What if there was a diagonal line? So let's draw a diagonal line right here. So let's say that there was a diagonal line right there that they want us to flip it over that diagonal line. So again, think about what we just did with all of those different lines, right? How far away is it from the line? We want to do that same thing here. So imagine how far away is C from this line? Well, it looks like C is about halfway through a box. So if I'm going to reflect C over this line, then this halfway through this box needs to be my new C right here. This needs to be C because it's reflecting over that line. Okay, Let me do that same thing for A. Okay, so A is right here. So A looks like, again, it's just going to continue going through that line, right? So it looks like it goes through, let's see, kind of goes through a half and then up 2 more boxes. So again, it's going to go through this half and then up 2 more boxes. A is going to be right here. Or we can kind of look at like what happens with A and C. It goes over 2 and down 3. So let's see. We want to go over 2 and down 3. It should be right here. Sorry, I put it over 1. 1 too many. There we go. I can't erase that point for some reason. Okay. And then B, again, we want to see how far away is it from this line. So if I were to draw that perpendicular line, I kind of notice that it goes through 1, 2, 3 diagonal boxes and then a half. So I'm going to go through this half and then I'm going to go through 1, 2, 3 and put my new point right here. So let me use these to kind of pull it over here. Okay, so this one's going to be B. And then C was here. And then A is here. So again, notice it's this exact same triangle. They're perfect images. The only difference is I'm taking C and putting it over here. And I'm taking A and putting it over here. And I'm taking B and putting it over here. And it's a perfect reflection. The things that are on this side, flip to this side. The things that are on this side, flip to this side. So again, that was just a review of the reflections from yesterday. Again, you have a couple more practice problems today in the homework, so I wanted to make sure that you understand that. And then now let's talk about translations. Translations are my favorite dilation, or my favorite transformation, because they're super easy. If I'm translating something, thinking about language, when I'm translating a language, I'm saying the same words, I'm just saying them differently or in a different language, right? A translation doesn't change anything. It just moves it around. So reflection flips. If I were to give it a one-word definition, reflection flips, translation moves, just moves. So I'm going to have this exact triangle in a different spot. It's not going to flip, it's not going to turn, it's not going to do anything, it's just going to move, right? So if I were to say, and the directions will tell you how to translate it. So it might say translate up 5 units and left 3 units, okay? So let's say that it says something like this, right? Up 5 units or left 3. The other way that it might say is it might say X, and then it might have a comma and it might say X plus, wait, left, so that's minus, sorry. X minus 3. And then it might say Y minus, or plus 5. Okay, basically what this is telling you to do is for my X values, move them left 3. For my Y values, move them up 5. I wrote them backwards, but it'll look like one of these two. So it'll either actually tell you, okay, so from here, we are going to be taking, whoopsie, let me zoom in a little bit more, but let's drag this down, okay. So it says up 5, left 3. So we're going to be taking this image of A, and we are going to be moving it up 5 and to the left 3. So here we go. We're going to go up 1, 2, 3, 4, 5, and to the left 1, 2, 3. This is my new A value. I'm going to do that same thing for C. I'm going to go up 1, 2, 3. Well, here, let me grab a C. Okay, so from C, I'm going to go up 1, 2, 3, 4, 5, and to the left 1, 2, 3. And then same thing for my new B value. I'm going to go up 1, 2, 3, 4, 5, and to the left 1, 2, 3. Notice these two triangles are literally the same triangle. The only difference was we moved it around on the screen. Because that's what a translation is. It's just moving something. You are not changing the direction. You are not changing the way that it's facing. All you are doing is just moving it around. Okay? So think of if I have this one, right? Let's say I have this and it tells me X x plus 1 and y minus 2. So essentially this is telling me for my x values, that's left and right, I'm going to move 1. For my y values, up and down, I'm going to move -2. So for this point, let me bring this over here so that way we can see it, right? Here's, okay. So from this C point, we'll start with C just because of C, right? Here we'll put A here and we'll put B here. Perfect. Okay, so from this, we are going to take x and we're going to add 1 to x. So right now, x is right here. So if I'm adding 1, that means I'm getting positive, so I'm going to go this way 1. Perfect, right there. But then it also tells me to subtract 2 from the y value, which means I'm moving 1, but I'm also going down 2. Perfect, that's my new c value. I'm going to do that same thing with a, so it's right here, so I'm going to go over 1, down 2. That's my new a value. And then same thing with b. I'm going to go over 1, down 2. Perfect. Again, notice it's the exact same shape, it's just moved around. Okay? X is left and right, y is up and down. That's what a translation is. So again, there's a second video that you can watch to show another example of it. Again, you want to pay attention to the one-word responses or the one-word definitions, because that's going to be on your assignment in a second. If it asks you, what is a one word that describes what a reflection is, you would say flip. It just flips it over the screen. If it were to ask you what is the one-word translation or one-word definition for translation, we'd say move. It just moves it around.